Hi students, today we will discuss regarding simple stresses and strains, the first unit of strength of material. So let us see first what is stress. Stress is defined as the force of resistance per unit area offered by a body against the deformation. What is stress? It is defined as the force of resistance per unit area offered by a body against the deformation. Means whenever we apply external force on the body, what happens? It will undergo some resistance. So it will withstand some resistance, which is known as the stress. Means whenever you apply some load on the any component, it will offer some resistance to that external force applied. That resistance, what it is withstanding, it is or offering for external force, that resistance per unit area is known as the stress. So the external force is known as what? Load, and the stress induced in the body as long as the external force is acting on it. So I will illustrate this same thing with some small example so that you'll understand clearly how the stress will going to act on a body. Just a minute. Please watch over this video. You will understand the concept of stress.
When we are stretching the spring, the deforming force will act in the outward direction and the restoring force will act in an opposite direction, that is, in the inward direction. Similarly, when we compress the spring, the deforming force will act in the inward direction and the restoring force will act in the outward direction. The restoring force will always be equal in magnitude and opposite to the direction of the deforming force. The restoring force per unit area is known as stress. For example, if a force of magnitude F is applied to a body of cross-sectional area A, then the stress will be F by A. The S
Here clearly we can understand the concept of stress. So this wooden block is attached to the spring. So when external force F is applied on that wooden block, what happens? Due to the external forces applied from the force F, the wooden block will be under external force, but that will withstand because of external resistance offered by the body against that external force, and that is per unit area. So that is how the stress is measured. Stress is equal to force upon area. The unit of stress is Newton per meter square, or also you can write it Newton per mm square. And the dimensional formula for the stress is ml minus 1 t raised to minus 2. So this is the dimensional formula for the stress.
SI unit of stress is Newton per meter square and its dimensional formula is ml raised to the power minus 1 t raised to the power minus 2. Stress can be classified into three types, that is longitudinal stress, tangential or shearing stress, hydraulic stress. Let's understand them in detail. Let us do an activity to understand the longitudinal stress. Take a cylinder made up of clay and stretch it from its two ends. so that the applied forces are normal to its cross-sectional area. You will observe that the length of the cylinder has increased. In this case, the restoring force per unit area, that is stress, is called tensile stress.
We will come back to this. So before that, we'll go to the notes. I think you understand the clear concept of the stress. So stress is defined as the force of resistance per unit area offered by a body against the deformation. And the force which you are applying, it is called external force or the load. So stress can be noted by like this: sigma stress induced in the body, and P or F is the external force or load. Uh, its unit is Newton, and A is cross sectional area of the member, which is taken in mm square or meter square. What are the units of stress? Stress units are taken in Newton per mm square, and force is in Newton, and cross sectional area is in mm square or meter square. So this is about the basic introduction about the stress. Now let's come to the next thing. Next is conversions. Here we can see why these conversions I mentioned here, because when you are solving the problems, stress may be given in the Newton per mm square, or sometimes they will give in megapascal. That time you will get confused what is Pascal. So here 1 Pascal is equal to 1 Newton per meter square. And what is 1 bar? 1 bar is equal to 10 raised to 5 Newton per meter square, and 1 Newton per mm square is equal to 1 mega Newton per meter square, or it may be also written as 1 megapascal. Why it is written 1 megapascal? Because Pascal means 1 Pascal means is equal to 1 Newton per meter square. So these are the conversions. During the problem time also we will discuss regarding this deeply. So what are the types of stresses? There are mainly three types of stresses we are considering. The following are the stresses are commonly considered when a body is subjected to external load. What are those? Tensile stress, compressive stress, and shear stress. What is compressive stress? It is defined as the stress induced in a body when subjected to two equivalent opposite pulls. So here you can see a rectangle block is taken, uh, and both the side external forces are applied. So both the forces are here. Both the forces are here. Opposite. Both our forces are opposite. Just a minute. I want to show with some. Here you can see uh, one external force is applied on this side, and here applied this side. Here both the two forces are applied to this rectangular block. Both these forces are opposite. When two equal and opposite both are both the two forces are equal and opposite, and it pulls the rectangular block both the sides, and due to that what will happen, the length of this rectangle block will increase, whereas the diameter of this rectangle block will decrease. As a result of this what will happen, increase in the length and decrease in the length and decrease in the cross sectional area. So like this, mathematically mathematically it is written as tensile stress, that is sigma T, is equal to resistance to the force upon cross sectional area, or is equal to tensile load upon the cross sectional area. So same stress definition, force upon area, but here they are taken tensile load. They are taken the tensile load upon cross sectional area. So this is about the tensile stress. So now next comes compressive stress. Let's see what is compressive stress. As we know, discussed, um, in the tensile stress, this external forces are two equal and opposite pulls, but here in the compressive stress it is two equal and opposite push, but use the word here push, there it is pull. As a result there is a decrease in length of the body and increase in the cross sectional area. Here what happens, it will cross sectional area will increase here, but whereas in the tensile stress what will happen, length will increase and cross sectional area will decrease. But whereas in this compressive stress, length will decrease, because here you can see both the side two equal and opposite push are there. When you push this rectangle, both the side, what will happen, this rectangle will get compressed. So because of that, length will decrease and cross sectional area will increase. So now what is definition of the compressive stress then? It is defined as the stress induced in a body when subjected to two equal and opposite pushes. As a result, there is a decrease in length of the body and increase in cross sectional area. So what happens? Same definition in the tensile as well as in the compressive. It is also defined as a stress induced in a body when subjected to two equal and opposite pushes. As a result, there is a decrease in length. Same what you write there. It is defined as a stress induced in a body when subjected to two equal and opposite pull. As a result of their increase in length and decrease in the cross sectional area. Whereas in the compressive stress, what will happen? There is a, because of two equal and opposite push, whereas there pull. Here it is push. As a result, there is a decrease in length of the body and increase in the cross sectional area. And it is written mathematically, compressive stress is equal to resistance force upon cross sectional area, or compressive stress upon cross sectional area. So this indicates the compressive stress. It is also expressed in Newton per mm square. Next definition is shear stress. What is shear stress? It is defined as the stress induced in a body when subjected to two equal and opposite forces acting tangentially. This is mainly considered with reference to the riveted joints. So there you will understand this clearly. So let's first see what is shear stress. Shear stress is when it is defined as a stress induced in a body when subjected to two equal and opposite forces acting tangentially. Two equal and opposite forces acting tangentially. Here, main important word is tangentially. How the force is acting? Tangentially across the resisting section. So, across the resisting section, tangential force is acting. Because of that, the area will be under the stress. So, that type of stress is called the shear stress. So, how this type of stresses are expressed, it is also expressed in same Newton per mm square. So we'll go to once again to the video so that you'll understand clearly about the concept of stress and strain.
Download Byju's, the all-new and personalized learning app.
आज मैं सबके सामने ये ऐलान करना चाहता हूं कि अगर फेसबुक नहीं होता
stress. Now take another cylinder of clay and compress it from both the sides. In this case, the length of the cylinder has decreased and the stress in this case is called compressive stress. Tensile stress and compressive stress are known as longitudinal stress. In both the cases, the length of the
Just now I explained the two types of stress. One is tensile and the compressive. Here also you can see the clear understanding about the animation of tensile stress and compressive stress.
object is changed and the ratio of the change in length delta L to the original length L is known as the longitudinal strain.
Here you can observe they are explaining also the strain. Will come about the next part. Here delta L is what? The change in the length or a decrease in the length. So if the change in length by original length, they are indicating by longitudinal strain.
Let us now understand what is tangential or shearing stress by performing a small activity. Once again, take the clay cylinder and apply force using your hands on both the faces of the cylinder in opposite directions. But this time, the force should be parallel to the cross-sectional area. You'll observe that there is a relative displacement between the two faces of the cylinder. The stress developed in this case is known as tangential or shearing stress. The ratio of the relative displacement delta x to the length of the cylinder is known as shearing strain. The expression for shearing strain can be written as shearing strain delta x upon L is equal to tan theta. Here, theta is the angular displacement of the cylinder from the original vertical position of the cylinder. Generally, the value of theta is very small. Therefore, tan theta is nearly equal to theta.
So as I was explaining regarding the shear stress, so here shear stress or you can say tangential shear stress. Here in this they are explained clearly about the shear stress. I'll take little back.
The cylinder from the original placement expression for shearing strain can be written the ratio of the between the two faces of the cylinder. The strain of both the faces of the
Here you can see when these two forces are applied opposite parallel to the straight line. So where is the straight line? Here. Just a minute.
cylinder in opposite directions. But this time,
Here you can
force
see
should be
the
parallel
straight
to
line
the
is here.
cross-sectional area.
Along this
You'll
straight line,
observe that there is a relative displacement between the two faces of the cylinder. The stress developed in this case is known as tangential or shearing stress. The ratio of the relative displacement delta x to the length of the cylinder is known as shearing strain. The expression for shearing strain can be written as shearing strain delta x upon L is equal to tan theta. Here, theta is the angular displacement of the cylinder from the original vertical position of the cylinder. Generally, the value of theta is very small. Therefore, tan theta is nearly equal to theta. Now, let us understand what hydraulic stress is. Take a solid sphere ball and place it in a fluid. Under high pressure of the fluid, the ball is being compressed uniformly in all directions. The force applied by the fluid acts in the perpendicular direction at each point of the surface, and the ball is said to be under hydraulic compression. This compression will lead to a change in the volume of the spherical ball, but there will be no change in its geometrical shape. Internal restoring forces are developed in the spherical ball, which are equal and opposite to the force applied by the fluid. This
is another type of stress, that is hydraulic stress. So hydraulic stress is required to study whenever you are using the oil under the pressure and external forces are applied. Especially hydraulic stresses are very essential when you are lifting very high load or in the operating the hydraulic different types of press or the machines. Here it will give the clear understanding when you submerge the ball into the water or in the oil, so that will be under the external force. So with animation here clearly you can understand the yellow color pressure is exerted on the ball and the restoring forces from the ball is applied exerted exactly to the opposite to the pressure which the oil or the water is exerting on that spherical ball. Same has clearly and very easy understanding has been given in this video.
internal restoring force per unit area is called hydraulic stress. The magnitude of this stress is equal to the magnitude of the applied force per unit area. The strain produced in this case is called volume strain, and it is expressed as the ratio of the change in volume delta V to the original volume V. Strain has no
So also this is called volumetric volume strain. Volume strain means what? Change in the volume upon original volume. So whenever you dip that spherical ball into the water or in the oil, so what will happen? There is a change in the volume. So initially original volume was present, but when you dip that spherical ball into that tank, so what will happen? There is a change in the volume upon original volume. So that is called volume strain or volumetric strain.
units or dimensional formula, because it is the ration of the change in dimension to the original dimension. The mathematical relation for stress and strain was given by an English physicist, Robert Hooke. He performed experiments on springs and found that the elongation, change in length, produced in a body is proportional to the applied force. He presented his law in 1676, which is known as the Hooke's law. The Hooke's law states that the strain in a solid is proportional to the applied stress within the elastic limit of that solid.
So this next part is Hooke's law. What is Hooke's law? So Hooke's law states that the strain in a solid is proportional to applied stress within the elastic limit of that solid. This experiment already performed in the science lab to find stress is directly proportional to strain. So Hooke has stated this: whenever there is a force is applied within the elastic limit, the stress is directly proportional to strain. So that you have been already proved with the help of the Young's modulus experiment setup. The same thing has been explaining here, so that the whatever the amount of strain is developed is directly proportional to the stress.
Thus, stress is proportional to strain, or stress is equal to K into strain, where K is proportionality constant and is known as the modulus of elasticity. The Hooke's law is found to be valid for most elastic materials, though there are some materials which do not follow this law. Let's recap. The restoring force helps the elastic materials to regain their original shape and size. The restoring force will always be equal in magnitude and opposite to the direction of the deforming force. The restoring force per unit area is known as stress.
So the whole concept of this recap is to understand whatever you learned till. So restoring force means what? Whenever you remove the force, so what it will does, it helps the elastic materials to regain their original shape and size. Whenever the external force is removed from the body, what will happen? It will regain its original shape and size. So the next point is that the restoring force will always be equal in magnitude and opposite to the direction of deforming force. So whatever the external force is applied, and when you are removing that, and it will be always equal in magnitude. Magnitude means what is the maximum amount of force you have applied, magnitude, and opposite to the direction of the deforming force. So the next point is the restoring force per unit area is known as stress. Stress has a different definitions, so I will provide the notes, so refer that notes. Today we will have only about the basics of the stress and different types of stress. So in the next class we'll discuss about the strain and different types of strain. So that's it, and I'll supply the notes, I'll transfer the notes in the WhatsApp, and the same thing you write in the your notes book, and resend it to my email address. I will send their email address. So according to the your mail I will receive, I will going to give a attendance to you. Thank you.